Alright, welcome back. This is section 2, creating our first prototype. So as I said, we're going to jump right into it here, but I want to go over a few things real quick before we jump into the code. So why prototype? What's the point of it? Well, it's an important step in the game development process. It's where we test ideas, we test tech, and we sort of test scope and see what feels right in terms of how big to make a certain feature or game, for example. So it's a good place to riff ideas in a throwaway environment, meaning I know that this code is not going to stick around, so I can try crazy things and see what sticks. Right? I can estimate the effort for complex tasks, by actually putting some code down, writing it down. I can actually see, okay, this is actually seeming to be a little bit harder than I thought it would be. And then you can adjust accordingly. You can also figure out what's feasible in a given period of time based on that. So it may be that you want to make all these features, but you want to get them done in a certain period of time. You may have to cut some corners there if you figure out during prototyping that something just takes longer than you thought it would. And then you can throw away those bad ideas early. You don't have to stick to an idea if you prototype and figure out that it's just not fun or it's not working for your game. So we're going to start our prototype here for creating a character controller. The game type we're going to go with is sort of a clone or sort of a mishmash of a roguelike and a Smash TV kind of clone. So if you're not familiar with those, a roguelike is just sort of where you have these randomly generated dungeons, items, and enemies. And in a Smash TV, it's sort of this game where you have oncoming waves of games, the top-down shooter, and you have waves of enemies coming down at you, and you just want to clear the room before you move on to the next level. So let's talk about creating our character controller first. I have a scene already set up, and you can see here from previous videos I sort of showed you that I like to break things down into folders that represent a part of the game. In this case, our prototype is its own section, and I can throw away this folder entirely later on if I want to. But for now, I have the things that I need, which are materials, and that's just for the floor here. You can see it has a custom material, just a checkerboard so I can see movement more easily. My scenes was my controls test scene, which is this one we're in here. And then two scripts. One is a camera driver, which we'll get into in the next video. And then the character controls, which we can dive into now. So as you'll see, I try to follow those coding conventions that we talked about earlier. And one thing that you may notice is that even though I have these fields set to private, for example, our actor field and our move speed modifier, I want to be able to access those from the inspector. So what I do is I add this attribute called serialized field right before it, and that will make it show up in the inspector. And I'll show you that in a little bit. So let's see here. Actor, what is this? This is a concept I like to sort of play with because sometimes you just want to reference the game object that a script is attached to, but this gives you a little flexibility to say, actually, my root object doesn't necessarily have to be the one with all of the components on it. So I can specify my actor specifically, and the actor is just the game object in the game world representing this character or entity. So actually, let's add that here so that we're clear. And then we have a few values here. We're movement and speed. So we want to be able to tweak the speed at which our character moves. This is not a one-to-one relationship. This is just a multiplier. So the movement speed is linearly multiplied by this value. And then we have two sort of private fields here that we use internally, mouse position and look direction. So another thing you may notice is that I don't put all my logic in one place, right? I could have put all of my code right here inside of handle input, but instead what I've done is I've broken it out into separate methods. And even though I may throw this code away at some point, this is sort of a no-cost approach to doing things, and it helps me organize the scope sort of relevant to what the thing should do. So handle input does a few things. Get input just gets input. Get mouse input just gets the mouse input, right? And I could even name these a little bit differently, but for now, for prototyping, this is fine. And if I do want to salvage any of this code for the final game, I can just take one method and, be happy with that, as opposed to if it were all in one big monolithic method, I'd have to think about it twice. So another thing is fixed update. Now, we're not going to quite get into the update loop in Unity quite yet. We'll look at that further on in this course. But for now, just know that there's update and there's fixed update. The reason why you might want to use fixed update is because it's called at a fixed rate, which is, as the name implies. And this is good for getting sort of smooth, consistent movement. And I'll show you the difference in just a bit here. So we call handle input from inside, and handle input gets two things. It gets the mouse input, and it gets input from the keyboard. One is applied to the rotation, and the other one is applied to the translation, so the movement of the character. So let me show you how the character moves before we go on, just to sort of make that clear for you. So the character can do sort of two things. Oops, and actually I have my settings wrong here from a previous take. So let me reset that follow offset, and we'll get into that in the next video, don't worry. So you can see here, I have a top-down view, and as I rotate my mouse around the character will sort of follow that. Separately, if I use the WASD keys, I can move around. right? And I'm actually strafing left, right, and I can move independently from the way I'm looking, which is sort of a staple of this type of game. Now, you may be wondering, why WASD? Well, those settings are set inside of your project settings and input up here. And that's the default that Unity ships with at this moment. I'm sure somewhere in the 2018 cycle they may release their new input system, but for now this is how it works. And so your horizontal axis is mapped to certain keys, the A and D keys, and then your vertical is mapped to the S and W, so WASD. Pretty standard for games, but that's where we get that from. You'll see these names, horizontal and vertical, pop up again. So let me get into that here. So when we do get mouse input, actually let's start with get input because it's a little bit simpler. So let me go to that first. So get mouse input. Or sorry, keep jumping back and forth. We're getting input here, which is the keyboard input. And so vector input, we just sort of initialize it here at 0, and then we get the X from the horizontal axis, which is what we saw just now, and Z from the vertical axis, so W and S, right? And you may be wondering, why Z and not Y? Because Y is generally associated with up. Well, it's like I showed you earlier, because it's a top-down view. If you notice here, I'm looking at it from the top. I want the Z-axis to be up, in this case forward, and X to be my left and right. If I were in a side-scrolling game, then yeah, my Y would be up because I want to be able to jump or whatever. But in this case, it's top-down, so my up axis is the Z. And so we return that value there. And so what we do with this value once we have it is we translate, and this is just a method of the transform. We give it a vector, the direction we want to move in, which is the vector we just gave it from the input. We smooth that over delta time. And so delta time gives us the difference between the last frame and the current frame. My input is at, full input, which is 1.0. I'd want to move 1 unit every single frame because then, I press it down, I move too fast. So I smooth that over. I want to move over time, multiplying by the delta time. So this will be a small value, very tiny value, because frames generally drop pretty quickly depending on how performant your game is. And then I want to sort of modify that by the speed modifier, which we looked at earlier. So in this case, it's set to 3 by default, but you could tweak it in the inspector. So if I look at my actor here, I have the ability to tweak that. So let's make it like 8, something that's much higher. And the other thing you'll notice is that I pass in space.world. So I'm moving relative to the world, not relative to my game objects. So no matter which way my actor is rotating, up is forward, down is back, right is right, and left is left, regardless of rotation. Because I'm moving relative to the world, not to this game object, or to its transform rather. And the other nice thing that you'll notice is I can tweak the value of movement. So if I want to make this, it starts at 8, right? And I set it to 80, right? It happens right away in code because we're reading it from that variable at runtime. Okay, so let's back up here a little bit and look at the get mouse input. I left this one second is because it's a little more involved. So let's take a look here actually at this top view. So the first thing we do is we get the mouse position, and this is a Unity method to get the position of the mouse relative to the screen in pixel coordinates. So what does that mean? If this is my screen here, and it's set to 1024 by 768, then the coordinates are relative to the 0, 0 position in the bottom left corner. So this would be 0, 0 here, and up here would be 1024, 768. But in reality, what I want to do is get the 0, 0 to be the same as the middle point, because I know my character is going to be in the middle of the screen. This wouldn't necessarily work for any type of game, but in this case, I know that my center is in the middle of the screen. So what I want to do is that when I rotate around the character, I want to get that axis. I want to get the angle between where my mouse is and draw a line down to the character and sort of see what that rotation should be. And so what I do is I make the relative mouse position by taking the position I got earlier from Unity, and I offset it by half of the screen width and half of the screen height. So if 0, 0 is here, I actually want it to be up here, right? I don't want it to be down here. So 0, 0 is here. So by offsetting it like that, so let's say this was 512, by minusing that, then I'm making it to be 0, 0. So I hope that makes sense to you. And then I get the angle using a math function. And you can look at the documentation for what A10 does. I didn't want to get too deep into math here, but essentially we're going to get an angle from this vector here relative to the x. So relative to this flat, so this x-axis, I'm going to get an angle based on the other vector. So let's say I have my mouse is straight ahead, right? I'm looking at top down, straight ahead. So that would be the 90 angle, right? So I'm going to get the angle between the x-axis and this vector from 0 to where my mouse is. So that's going to give me about a 90-degree angle, right? This method actually returns radians, so I have to multiply by mathf.radians to degrees, essentially. That way I'll get degrees back. And then I multiply that by -1, and that's just a little quirk of the coordinate system here that I'll show you in a second. So if I look at my character, you'll see that when my mouse is straight up, I'm actually at -90. When I'm straight down, it's at more or less 90. And so that's sort of taken care of here. Finally, we get a quaternion, and a quaternion is a way of representing rotations. In this case, we have some helper methods that Unity gives us, so we use angle axis. So we're going to get a rotation relative to a certain vector by a certain angle. So in this example, I'm giving it vector3.up, which would be the green axis here. I'm saying rotate about that axis by a certain angle. The final result, when I get back, is a quaternion that I can return, and then I just apply that rotation straight to my transform, right? So when you see it all come together, essentially I have the character following the mouse, as it should be. And that's why the character has sort of this little cube inside of him, just so I can see which way is forward. And this all works great. So one of the things that you may notice is that everything's set up relative to what my gameplay is. So that's important in prototyping. I only want to prototype the way my game works, right? And I want to cut out any other things. I don't want to use generic stuff if I don't have to. I saw a few methods of handling this particular problem, following the mouse, where, for example, imagine you're looking at the game view through the camera, and wherever my mouse is, there's a method which would shoot a raycast into space and then hit a plane and sort of tell my character to look towards that intersection point. That works fine, and there's probably scenarios where that's good, but this seems a lot simpler to me. But you may find that you may need something a little more complex for other types of games. For here, this works. Okay, the other thing that we sort of glossed over is the camera. So we'll look at that in the next section. But for now, it'd be good for you to review the code and sort of tweak these values and see what happens if you were to change the order of things. Another thing I recommend is that you debug log the values in this code to see what's happening. Each part of this, log out the mouse position, the screen width, and see how those values are changing so you can better understand how you get to the final result of this whole sequence of events. All right, so that's it for now.